This video covers programming methodology, moving from machine code to algorithmic logic. Computers are obedient machines, but a communication gap exists because they don't understand natural language. Programming languages solve this by translating human intent into machine-readable formats. The 5 basic instructions of any language are the vocabulary of computation. User intent is translated via a programming language into binary or hardware instructions. These instructions include input, output, math, conditional execution, and repetition. The first generation is machine-level language, the native tongue of the CPU. This is the only language a computer understands without translation, consisting only of binary digits, or zeros and ones. Instructions are structured with an opcode, which is the command, and an operand, which is the location of the data. Evaluating machine-level language involves a trade-off between speed and usability. Its advantage is fast execution speed, since the CPU understands it directly. However, it is machine-dependent, difficult to program, error-prone, and rigid, making modification challenging. The second generation introduces assembly language using mnemonics. The core concept is replacing binary codes with alphabetic abbreviations for operation codes. Mnemonics are memory aids for instructions, and it uses symbolic addressing instead of absolute memory addresses. The assembly execution workflow moves from source to execution. The source code is translated by the assembler into object code. The linker combines modules and creates the executable, which the loader then loads into memory for execution. The third generation brings high-level languages, offering abstraction for human logic. Instructions are closer to English-like statements, completely abstracting away the hardware. This allows programmers to focus on problem logic. These languages require a compiler for translation. Examples include Fortran, COBOL, BASIC, and Java. Comparing the generations, machine language is fastest but not portable and difficult to use. Assembly language is fast, machine-dependent, and moderately easy with mnemonics. High-level languages are slower due to translation, but are portable and the easiest to use. Characteristics of a good language include clarity, simplicity, and unity for conceptual integrity. Orthogonality means changing one element doesn't affect another. Portability allows programs to transfer easily. Finally, support for abstraction enables the definition and use of complex structures. Algorithms are the blueprint, planning logic before code. An algorithm is a finite, step-by-step process to produce a desired result. Key characteristics are being finite, clear and unambiguous, and language independent, often written in pseudocode. Flowcharts are used for visualizing logic using standard symbology. Shapes represent different functions: ovals for start/stop, parallelograms for input/output, rectangles for process, diamonds for decision, and circles for connectors. Here is a practical example of translating an algorithm to a flowchart for summing 2 numbers. The steps start and stop, input values, calculate the sum, and print the result. The flowchart visually represents this exact sequence of operations. Procedural programming is a methodology using a top-down structure. The problem is broken down into procedures or code blocks, each performing a single task. This structure is appropriate for small programs with low complexity. For complex systems, object-oriented programming, or OOP, focuses on entities structuring code as data plus behavior, aiming for cohesive solutions through object interaction. Functional programming focuses on independent units, where problems are divided into self-contained functions that are stitched together. The developer ecosystem involves several key definitions. An editor is used to write code. A compiler transforms source code into machine language. A linker combines modules. A loader assigns addresses and loads executables into memory. A debugger helps test and remove errors. An integrated development environment, or IDE, combines these tools.